Na, o dabar pas mus sekantis pašnekovas, UAB Litnobiles partnerio Daugiau chemijai AG vyresnysis tarptautinis techninis konsultantas Osselmann. Please welcome Osselmann. Jis mums papasakos apie tiltų konstrukcijų hidroizoliaciją. Mr. Paul, stage is yours.
Okay, thank you very much. I'd like to thank the organizers and our partners here at Litnobiles for inviting me to come speak here. Yeah, I'm from Coaster, waterproofing systems in Germany, and I do consulting for all over the world for all different types of projects. I spent a few years working at the research center in Karlsruhe, and there I was doing life cycle analysis of major governmental building constructions. And if there's one thing I really learned there is that each construction has to be judged individually. They're like people, they have personalities and they have their own quirks and problems. And they live, they breathe, they sweat, they get sick. So when you have a construction, you have to really look at the problem individually, and that's what I do. Since we have a little time constraint, I have 20 minutes, I decided to pick out a few of our projects that are a bit interesting. Obviously, we can't get to all the methods and materials and systems that we have for waterproofing and for retrofitting and repair of concrete and steel structures. But we do have this bridge, the Second Severn Crossing in the UK, and that was a very interesting project, as a matter of fact. Prefabricated channels that are then bolted together and then post-stressed to hold them together. And they had lots of cracking in them. And due to the thinness of the profiles, we couldn't drill into it and we couldn't do the more typical type of concrete injection. So we used vacuum injection as a method we pretty much developed for this problem here. When can you use a vacuum injection? When you have a very complex network of cracks. And there's a danger of the concrete being damaged through further drilling. So we really didn't want to touch that concrete at all. Structural repair, obviously. It's also can be used in large floor areas very effectively, but not where you have active leaks. The advantages, you're also not touching the structure. You can do a large network of cracks at the same time, and we have gotten exceedingly good penetration into this system, as you'll see later in a few photos. It's not destructive, non-destructive to the concrete, and with the material we can also get a very good bond to moist and wet flanks, which this bridge is very exposed, and if you've heard about UK weather, today outside would be a beautiful day in the UK. Okay, how does it work? Well, we apply a vacuum to one side. So we have to have a pressure plate where the material is available, and then we're sucking it through to the other side and sucking it all through the network of cracks. The required equipment is these Binks pressure pots, because you can't allow air to get into the system, and obviously also a vacuum compressor. So we have the vacuum pump on the one side, and we have the injection side is where we're making the material available through the pressure pot, and then over these large pads that we also designed and adhered to the concrete, and then we're just pulling it all through. That's quite sweet how it worked out, as a matter of fact. What type of resin do you need for this? Obviously, you want a very low viscosity. The lower the viscosity, the better. The Reynolds equation of flow of a material, the lower the viscosity, the deeper the penetration, the smaller the pores you can actually pull the material through. Solvent-free, we don't want anything gassing off. Once we fill that, we want the material to cure and stay there 100%. No shrinkage. It has to be also, obviously, stronger and better than the concrete. But generally, when you're doing structural injection on a concrete, it's like a bone. If it breaks, it's going to be much stronger in that area. So you're never going to have a failure again in the original crack, but you're going to have, perhaps, if you don't fix the system, have cracks next to it, flanking it. And non-foaming, obviously. You don't want like a polyurethane that's going to react with the water. So we chose one of our injection resins. It's an epoxy. Very low viscosity for an epoxy, 100% solids, no shrinkage, compressive, tensile, flexural, all the strengths greater than a concrete. And we achieve also very good adhesion also to moist and wet concrete with this material. So here's a view inside of the bridge. You can see the section, and then we have the tensioners that run through there. And yeah, obviously, these are very thin sections. I was surprised how thin the walls were. They were like 10 to 20 centimeters in this precast concrete. And these, here, you see the tensioners at the bottom. This is obviously not a laser pointer. Okay, and the cable tensioners at the bottom. Here inside also, traffic, and here's where we had to work. So from the inside to the outside, here's one of the pressure pots, and then adhered packers. And these are the results. We got very excellent results. Here you see the top 0.34 millimeter crack width. We got full and complete filling. Here in the middle, 0.7 millimeters, also completely filled. Excellent results, excellent results. And finished that job successfully. You see it from the outside. So this is just one method, one solution that we found. As I said, if you every bridge is going to have its own problems, its own quirks, and if you have difficulties and need help seeking a solution, then please contact our partners here at Litnobiles. And in case they need any further help, they'll get in contact with me. At this point, I just did not want to not mention the more classical types of concrete repair. Obviously, there's reprofiling, there's removing damaged concrete from chlorides and sulfates and patch repair. And all these standard methods, I just think that taking an example of this more classical type of concrete repair would not be interesting enough for a conference of this high caliber. So this is a bridge though here. All the types of classical problems, spalling, corrosion. You're going to be doing your concrete replacement and repair, and then also covering it. It's never nice to see a repaired concrete when you're driving down the street. You want the concrete to look like it was still freshly poured and not have a bunch of patches and repairs on it. So that was covered up. And as the last example here, I'd like to introduce, also thank you for Mr. Alexandros Kaplis here for your excellent work. And he's here around here somewhere. I believe he is here. He's from Riga, and also he's our partner in Riga. And he's done a lot to help us along with this project. It's a new system for bridges and overpasses. There's a waterproofing layer, which we provide, and then there's a ballast and ballast mats. And it's already been approved by the Finnish Transport Authority and also by the Deutsche Bahn. So what we have system components, waterproofing membrane, that's a coaster TPO, also known as a FPO in certain markets. It's a thermoplastic polyolefin. It's a very long-lasting, very elastic membrane for waterproofing, which we also use on roofs and for structural waterproofing, all sorts of areas and details. The elements for the mechanical fixation are obviously also important and part of the system, geotextile and the ballast mats. And this has already been, as I mentioned, accepted as a complete system for waterproofing structures here. So this is the rail bridge. What we have is we have the rail deck on the bottom, then we have a sub-ballast mat, and we're going to protect that. There's also resins for epoxy for strengthening and hardening the substrate and making the concrete less pervious to water. Geotextile, the waterproofing membrane itself, another layer of geotextile, and then the Dam-Tech sub-ballast mats, different thicknesses according to the requirements, and then a fleece and the ballast is then installed on top. Very effective system. Advantages, obviously, what do we want to do? We want to maintain and keep the structure long-lasting. The first thing we have to do is protect it against water. That's really the main enemy. My old boss, I worked at the University in Berlin for many years under Professor Hillemeyer, and he said all of our construction is just a fight against water. Whenever we're building anything, we're always fighting water. If you can win that battle, then you're going to have a very long, effective life cycle on that building. While we're installing this, we want low dependence on weather conditions, so we don't, if you have a liquid applied system that needs to air off and dry off, either you're going to have a large infrastructure to cover that, maintain specific environmental conditions inside that for the curing, and that takes time. But if you have a membrane that can be hot air welded, also in wet conditions, then you have a huge advantage. You're not as dependent on the weather conditions. Using this system, very low requirements on the substrate preparation. As you know, classical structural waterproofing, very often you have very high requirements on substrate preparation. We're talking sandblasting, grinding, all sorts of different methods. That is quite expensive, time consuming, but with a membrane you can basically go over the old surface, no matter how cracked or poor it is. Membrane applications, you can install them up to 40 degrees. You can install them to below -5 degrees. And then we have part of the system, the underballast mats, absorbs vibrations, reduces acoustic transmissions. Obviously, also a factor when you have bridges and you have people living in that area. You want to keep the sound transmission to an absolute minimum. And reduce the ballast maintenance. The stones that they put on top of these railways, they move around a lot. So here, the substrate preparation, a simple sweeping. And here we have the Costa TPO 2.0 waterproofing membrane. Also, it's quite easy to install. There's a very wide range of accessories. For drains, we have all the details. How do you attach it to vertical areas, and automatic welding machines makes it quite productive installing this membrane. So here we have the rail deck. It's been then finished waterproofing with the membrane. And then this is the membrane itself. Thermoplastic, TPO, you might be familiar with these type of materials. If not, that would be a presentation for another time. Get in touch with us if you're interested in them. Mechanical fastening, loose laying, homogeneous seam by hot air welding, aging, rot resistance, high cold flexibility, which is very important. Very often we have the question, well, is it resistant to -20, -40, -50 degrees? And you can say, well, the colder it gets, actually structures themselves like a typical building will also stop moving at these extremely cold temperatures. And then when it warms up, it's going to move again, but the materials are also going to regain their elasticity. But obviously something like a rail bridge, through the vibrations and mechanical stresses, they're always moving no matter what temperature it is. So you have the cold flexibility, -50. Very environmentally friendly, recyclable membrane, chlorine, plasticizer free. You get leads points for it when you build with it. Details, the devil is always in the detail. You know, look at the structure itself. How do we want to fasten it? Where can we fasten it? It's going to be loosely laid, and mechanical fastenings and fixings are part of the system. So details are available on request. And then we have the sub-ballast water protection, also very, very important. Here it is being installed on top of the membrane. And that, as I said, reduces the shock, the acoustic transmission, and also protects the waterproofing membrane from the ballast. So here we are. We have the finished membrane. In the back there, you see the rubber mats are being installed, also all part of that certified system. And what comes on top of that, well, we're going to have our ballast. And here you see Obviously, very high mechanical impact simply through the installation of this very, very coarse stone layer. And no problems, it's perfectly safe. Here's the fleece on top of the geomat so it can drain properly. And that was it. Oh, I see, I still have 5 minutes left. So that's exactly why I sometimes build a false floor into my presentations. So while I have the opportunity, as I said, there's lots of different methods and materials for waterproofing bridge decks. What we also have in our program is the CT225 bridge deck coating. And if you're aware of the regulations that ZTV-ing, sorry, I only know that in German, there's systems for an epoxy that is required on top of a bridge deck before other layers are applied to it. And we have it. We have the CT225, typical surface preparation, mixing the two-component epoxy, application to the floor. It's also exactly predefined in the ZTV-ing and then the Bell SB, I believe is the name of the other code. It has to be filled with a certain amount of quartz sand, and that's also exactly defined in the regulations and also in the technical data sheet. And then we have a bridge deck waterproofing membrane, it's the ECB. Ethyl copolymer and bitumen membranes are very closely related to a TPO that's used here in this system on top of the epoxy. It's applied over a hot melt system. This system has been in use since the 1980s and has been proven to be fantastically successful. So very often these bridges still have no damages on them since the 1980s. It's a fantastic system. Through this hot melt, you're guaranteeing that there are no air voids. Now that's the biggest problem. That's like a pinhole in your system or in your coating. That's the weak spot, and that's where the problem is going to begin. So if you use this installation method on top of that approved CE certified resin and application system, you're going to have a very long-lasting waterproofing. Here we have testing, crack bridging at -20 degrees, at -30 degrees. It's very, very resistant system. So, as I said, there's lots of methods and materials available, and each bridge or structure should be looked at and judged individually what would be required, what's the best long-lasting, durable, and economic and applicable system. Okay. Okay. Well, thank you very much for your time, and again for the invitation and for your interest.
Thank you. Thank you.